All right, today in class we learned about rational expressions, and this really ties on to what we learned with our exponents. Okay, so we're going to evaluate rational expressions in both radical form and rational exponent form. So the first concept I'm going to talk about is a square root. So this says for any real numbers a and b, if b squared equals a, then b is the square root of a. So I showed an example. I said if you had 4 squared, this equals 16. So if I come over here, then this says 4 equals the square root of 16. Now, if there is not a number right here, we know that that is a 2. And one way I talked about understanding this is this number means that if I break this number down, I need 2 numbers that will multiply to be 16 and be exactly the same. So it would be 4 and 4 here. We have 2 of the exact same numbers that multiply to give you 16. So I use this a lot. I just say it takes 2 of the same numbers to bring 1 outside the radical, or that square root. Okay, the nth root for any real numbers a and b and any positive integers n, if b to the n equals a, then b is the nth root of a. So, for example, if I have 2 to the third, we know that 2 to the third is 2 times 2 times 2, so that's 8. But I can go the other direction with this. I can say 2 equals the cubed root of 8. So what that says is if I can break 8 down to 3 numbers that multiply to be 8, in our case we know it's 2 times 2 times 2, 3 of the same numbers, so it takes 3 2's to bring 1 out. I show another example right here. I have 2 to the 4th equals 16, or we can say 2 is the 4th root of 16. 16 we know breaks down to 4 times 4. And 4 and 4 break down to 2 times 2. So right here we can see there are 4 2's. So if we take the 4th root of 4 2's, it will give us 1 2. Okay, so there's a couple of things that you need to know definition-wise. We call A the radicand. That's not as important, but I want you to know that that's what that's called. But what is important is the radical. That's this symbol. If there isn't a number right here, then we know it to be a 2. And if there isn't a number, then a lot of times we say this is the square root. And that's okay if you call it the square root. Okay? The next thing is the index. That's what this number is called. When we talk about more than one index, we call it an indice. Okay, we have another definition. A rational exponent says let n be 1 to the nth. Rational, if you remember, these are numbers that can be written as a fraction. So I have 1 over n, that's my fraction we're talking about. Let a to the 1/nth be an nth root of a, and let m be a positive integer. And these are real formal definitions, and I'll show you how we will apply them. So this says if you have a to the m over n, then this bottom number becomes the index. The top number goes inside the radical with the a value. And what we're going to see a lot today is we'll have something like a to the 1/5. We use the 1 a lot. Okay, and if I get 1 to the a to the 1/5, this is the same as the 5th root of a to the 1st. And we don't really need this a to the 1st, so a lot of times I just leave it off. Okay, we can do this with a negative exponent. Now we just learned this in the last section. With the negative exponent, we learned that it's going to pull everything to the denominator of the fraction. So we're going to move it to the denominator, and then we're going to write it in radical form. this says a cannot equal 0 because if 0 was down here, then we would get 0, and so you cannot divide by 0. So as long as that's not 0, you can solve it. So for this first example, it says to write each expression in radical form. Remember that this bottom number of the fraction becomes the index. So we have the fourth root of 3 to the first. That top number becomes the exponent for the base. But because it's a 1, we do not need to show it in our answer. And that's our answer. What this means is that we would need 4 of the same number that would multiply by 3, or multiply to give you 3. And because we know there aren't 4 whole numbers, we know that that would actually give us a decimal, and they would be pretty small. Okay, on B, same idea. We take this denominator of the exponent, the fraction in the exponent, and it becomes the index. And the base goes inside, and we can put this 1 here. But again, because it's a 1, we don't need to show it. And that says we would need 6 of the same number that multiplies to be 5. Okay, we're going the other direction on example 2. It's going to give you it in radical form, and it wants you to express it in rational exponential form, or exponent form. So the base is still 7. This, if you remember, is the bottom of the fraction, and because there is no exponent right here, the top number is a 1. On B, same idea. We have 27 as the base. The 3 right there becomes the bottom of the fraction. The exponent right there gives us the top number. Example 3 is going to ask you to actually simplify it. So there's a couple ways that we can do this. I think you'd probably feel most familiar if we wrote this in radical form. So to put it in radical form, remember that becomes the index. And this tells us that we have to have 3 of the same number. Now, I know that 64 becomes 4 times 16, and I know that 16 becomes 4 times 4. So here we have 3 of the same number. We need 3 to bring 1 out, so the answer to this problem is 4. On B, same idea here. We need 4 numbers. Sorry about that interruption by the intercom. Alright, so that says we need 4 of the same number. Now, I know that this is 5 times 125. Now, because this ends in 5, I know that I can still divide by 5. So if I divide this by 5, I get 5 times 25. And I'm going to bring that 5 down. And this I can do again because I know that 25 breaks down to 5 times 5. So here you can see we have 4, and we need 4, so the fourth root of 625 is 5. Okay, on 27, now this is a little bit more complicated because it says, hey, we need 3 of the same number that multiply to be 27, and then we're going to square that. Now that squared, I'm going to tell you, can go either inside the radical or outside the radical, and I'm going to use it as outside. It's a lot easier to work with. So I'm going to think 27 is 3 times 9. 9 breaks down to 3 times 3. So I need 3 of these. So if I have 3 of them, I can bring 1 out, and that takes care of this piece, but I still have a squared, so 3 squared becomes 9. I'm going to show you how to type this in your calculator with the next example. Yep, right here. So the next example says to use your calculator. So you can either type on this one, remember that we can rewrite this as 125 to the 1/3, so you can either type that in your calculator as 125 raised to the 1 divided by 3, or you can even type right here alpha y equals and choose a fraction, or you can press the math button and then select this. I believe it's number 5 or 4, and then go that route. And that should, I think that if you choose the 4, it won't look like this. It'll already have the cubed root for you, and then you'll just have to type 125. Anyway, when you do type this in your calculator, it should give you 5. Either way, however you type that in. Okay, your last example, I want you to solve each equation. So to be able to solve this, we solved these in one of our previous units. So to solve this, as a reminder, you want to get the bases to be the same, and you want to change the bigger number to become the smaller number. So you want to think 3 to what power will give me 243? I know that 3 to the 3rd, we just did that, was 27. 3 to the 4th is 81. 3 to the 5th is, there it is, 243. So I'm going to go in and replace this 243 with a 3 to the 5th, because they are the exact same value. And once I replace them, if you remember, when the bases are the same, we can cancel them. And we set the exponents equal, and there's your solution. So on B, same idea applies. We want to say, how can I make this 32 become a 2? Or, sorry, have a base of 2. So I think we talked about a 2 to the 3rd is 8. 2 to the 4th is 16. 2 to the 5th is 32. There it is, right there, 32. So we're going to replace that 32 with a 2 to the 5th. Now there happens to be a 4x there, so we have to leave that. And this is equal to 2. Now because this second 2 does not have an exponent, I'm going to put a 1. And at this point we can cancel our bases, and then we have 5 to the 4x. If you remember from your exponent rules, when we have exponents stacked, we multiply. So this simplifies to give you 20x equals 1, and to solve this we divide by 20. So x is 1 over 20. Alright, I hope this helps you with your homework. Your homework is 5.3, Rational Expressions Worksheet. So good luck.